All right, so welcome back to the week 2. And what we're going to do today is continue on the continuous probability distribution, getting a lot more detail and try to complete 6B and also try to get most of 6C, right? So I think it's totally possible. So the first thing to do is try to get understanding about who are they, right? So PDF is just a name that we already know. CDF already know, but put in the context of continuous probability, they are following some kind of function format, continuous function format. So the key message is no difference to discrete probability. Their integration, so are you using a negative indefinite, positive indefinite? Just try to give a general definitions, right? Because sometimes you might end up with like that. We will learn that later, right? This is called normal distribution. So normal distribution never ends. There's a asymptote at both ends. So all that things about it, as long as the asymptote, you still can do the integration for the whole thing, and you can prove that's equal to 1. As long as that's satisfied, you confirm that is a PDF. All right. So the next part is more practically useful is, okay, given that is like say PDF is given, how would you calculate a given probability? So we have some exercise on that already, but I just want to using mathematics to streamline this calculation. So for example, if you're given fx, I can make it a very simple case. Say fx is 1/5 over the area from 0 to 5. Right? So what we're doing here is got a uniform distribute. Yeah, it's just like it's the diagram for this PDF is this. It's quite common, right? You can just do that. What we call that is this is the probability. Sometimes you call that fx, right? Cool. Given that, if you try to find a probability where x divide like that equal to 0.3. So this kind of question, like it's not necessarily did before, right? But it's not hard either. So what basically you're doing is, okay, I just need to find out where's 2, which is here. Now the question is asking me, I need to find out the B so that this part represents 0.3. Right, so without using, let's do a geometry method, right? Because this is a very simple case, let's do a geometry method, you get the answer straight away, right? Geometry method telling us the area need to be equal to 0.3, which is this little rectangle, 1/5, b minus 2, right? So you can solve what's b. B is 1.5 plus 3, so it's a 3.5. Double check, 3.5 minus 2 is 1.5. 1.5 times 0.2 is 3. Yep, is 0.3. So that's correct. So can you see how easy it is if it's a uniform distributed structure, right? Density function. All right, now more important is you need to derive a confidence level of method in terms of integration, so that in the future, if you check in a completely different PDF, you want this method still works. Can we do that? Of course we can, right? We try integration. So integration area are still possible. It's still 0.3 is the goal. So how do you write down the integration formula? It's from 2 to b. Yep. So you are doing fx dx. Yeah, that's basically it, right? So then you write it down. It will give you fx from b to 2. Okay, so eventually you figure out is fb minus f2 should equal to 0.3. So now you realize, oh, okay, effectively, I just need to find out this primitive of the fx. So this is where like indicate what is fx then. Fx is primitive function of fx. So what primitive is? Primitive is simply doing integration. So in a mathematical term, fx is, so now watch carefully, it's a, just here, you're no longer able to write x anymore because you already used x here. Remember, this is a signed area function that we learn when we do the integration. So you have to using a different, you have to using a different notation. You have to using a different notation about integration to get that primitive function. Now, do you understand that? We put it in the context of this question. The primitive is 1/5 dx. So your result is 5/x. Sorry, 5. So I think I got wrong. Right? It's a t. So 5/t. We just need to follow exactly the logic, right? Because we're using the t, but a t is from a to x. The result is 5x minus a. Okay, so that's basically is algebra method of primitive. Right, so you can check that into here. So what is f2? Let's do that. F2 is basically f2, a is 2 in this case, right? Let's this case. A is 2, b is x. Sorry, x is b in this case. So you just roll back into this above formula. You will find, okay, so this 2 is f2 basically is 0, right? So the second term is 0. So you only just need to care about FB. FB in this case is become b minus 2 divided by 5, right? So hopefully the whole process that I have discussed here is just to try to explain what is the integration after integration method. All right, so now you have the same thing. Do you notice that? If you're doing algebra or doing geometry, you got that. If you're doing a algebra integration method, you are still getting that. So that's no surprise. They both will end up with the same result, which means B is 3.5. Yeah, so the same thing. This result is that. But you can also just ignore this part, right? You can also try to do it properly at the very beginning. It's like 2/b dt over 5, which is 5t. So that's getting the same result. Okay. So I have done that in a very, very simple case. So this is the case where, like the first example, is where geometry is possible, right? So this is the example geometry is possible. Okay, now we have something different. We have something different. You were getting a much different question is somewhere. So in case, so example 2, right? Where is geometry method, geometry area calculation is challenging. So when the geometry area calculation become challenging, how would you do the similar questions? So I can easily set up example, right? Let me think about it. So first, I am set up something look like a fx. So we set up here is 3, okay, 0. But you have something calculated. Okay. So we call that fx is k x squared over 0 to 3. Right? Do we need any more information? You don't. Okay. So I will have the same question. I will have the same question, but I have a different setup, right? This is the 1, and then there is a b, which you don't know. I want you to find out the question is say find b where probability x greater than 1 less than b is equal to 0.3. Can we do that? So just think about that, right? So now geometry is totally, it's not an option anymore. It's no longer easy to calculate because that's something that you never know, right? It's a quadratic, but the principle stays, right? They stick around the principles. So, and also this question have additional layer of challenge. What's that? The K. The question is, what is K, right? So this kind of question, you should be confident when the question is set up, the K is already applied, already sort of implied. So let me show you, right? So first, the question, right? So first you need to find that K. First, just find a K. So how to find a K? You're gonna say this, right? Because from 0 to 3, K x squared, the x is equal to 1. So again, this is exactly shows how the application works using the definition, right? Because even it doesn't tell you what's the K, you can solve it. So what that result is, you can easily figure out the next step. Once you do the integration, it is 3 over k x to the cube, yeah, from 0 to 3. It's you loaded in the value, that's a 3 at the bottom, k, then 27. That's equal to 1. Yep, that's the equation now. It's getting straightforward. You can work it out. K is, that's 9, so k is 1 over 9. You happy with that? So now we can confirm. So that's why fx basically is x squared divided by 9. All right, so that's a very important thing. If you don't know exactly what is PDF, you should pause before you go ahead to calculate anything. And you work it out. That's the first step is clear. You know what is PDF. Now, let's do the second step. How can you write down a probability from 1 to b? So is that hard? No, it's not hard in the integration word because that's simply just say 1 to b. Then you put fx. And you can using x. Why? Because you don't have the x at the integration intervals, because that's a 1 to b. So you can still use an x. And nothing in particularly strange now. So you are going to have a 9x cubed times 3. Yep, that thing is down from 1 to b. So you're getting a crazy number, b over 127. That's equal to 0.3. Yeah, maybe the question I set up is a bit of stupid. Can I just modify a little bit to make it illustratively easier? Right, I'm just making this 1/3. So let's just do that. Now it's 1/3. Is it possible to do? Potentially it is, right? So now you are calculating the result is B3 equal to 9, right? It should be 9. So you can work it out. B is 10 to the power of 1/3. Just keep like that. And that's your result. So the question asks you, what is the B? So that the probability from 1 to B is equal to 1/3. You can calculate that. Okay, so I think after the second example, so are you confident how to do this? It's very easy. So I think the most important switching point from probability to integration is this one. Can you see, this is the requirement. Whenever you have a requirement, you will find very easily connect to a integration of PDF. It's integration of PDF. So that's the most important connection from your probability understanding to integration mathematical skills. So once you click these two, problem solving become very easy, right? So that's a step that we have done to sort of take a review, go through how the PDF is, what's the key criteria, and how that be using in a real example, and in what circumstance you should go shortcut, take geometry method, because if something can calculate like a triangle or rectangle, any shape, like a trapezium, you should do geometry. So yeah, that's easy because it's just literally 1 minute's work. But if it is become a curve, right? It's like square, cube, or like some other things. It's a curve, sine, cosine, for example, right? So now you can't do that anymore. You can't do the calculation of the area by like geometry. So what do? You're gonna using that to using the integration to calculate. Okay, so it's not done yet. Now we're going to introduce a couple of concepts that you have missed out from the 6B. So new concepts, right? So what new one? First one is called, what is a Q1, Q2, Q3, and Q4? The name is called quarter, right? So what's the quarter spelling? Quarter that become quantile. This is a quarter, right? Just change the last 3 letter, quantile. So what's a quantile mean? So apart from quantile, do you know there's other similar name called percentile? And there's also decile. Is it decile? Let me check because I might misspelling. Yeah, it is decile. All right, so let's just quickly start from quantile and then quickly cover the definition of this. This is nothing to do with integration. It's purely a probability concept and definitions. All I want you to just be confident. If you never know, it's fine. You just need to know the statistical rule definition for those terms straight away in one shot. So what's quantile? Quantile means, like, say, for example, what is Q1? Q1 means the X value, so that Q1 is the X value, so that probability from the left hand side, you don't really, maybe it's not X value, it's the, yeah, it's the X value, it's right. So we're just using two different X. One is the capitalized X, that's the random variable. The little x is a small x. So you can calculate. Okay, so Q1 means the x value, so that the probability of the random variable less than that value is 25%. So graphically, it means if I just draw a graph, right? I just randomly draw a graph. You can split out, say this is a Q2. So here is Q1. Here is Q3. So what basically Q1, Q2, Q3 did a very easy understanding job is that you split all the area underneath of the curve, which is 1, right, into 4 equal size area. So you basically split that area as 0.25. This area is 0.25. This area is 0.25. This area is 0.25. So Q1 is this one. So here is the Q4. That's actually is in lots of case Q4 as people don't care. It's the 100%. Correspondingly, you don't have Q0 either because Q0 means 0. So you don't need to, means not 0, means the starting point of your domain. Like Q4 is the starting point of, or ending point of your domain. Possibly Q1 and Q4 could be positive, definite, negative, indefinite, or positive, indefinite. So those are all possible. Okay. So once you got that, how would you do this question? And like nothing, right? So suddenly you know, oh, okay, Q1 is like 25%. Then it's straightforward. Q2 is da 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 da. Everything is same, 50%. Then Q3, everything is same, 75%. Does that make sense? Cool, right? Easy. But then I think I want to extend to the terminology of quantile versus something else, right? So what is other name for Q2? So we can just say, what is the commonly used the other name that in statistics? So other name starting with, what's the median? What's median? Median actually is the same thing. Median you can just straight away, if you don't mind, I'm just straight away tell you. Median is Q2, means it's the X value in the diagram where you're cutting the total probability into bisect the total probability, median means, right? So it means left-hand side of the probability is equal to the right-hand side, which exactly stands for Q2. It also stands for 50th, right, percentile. So let's just search up the website, say what is the language correct way of saying this, right? How to say, I would say 50th percentile. I think it is, right? In out of 50% of the measurement under is the value, the 50th percentile. Yeah, I think is correct. So if you search on Google online, you can search 50th percentile, it will tell you it is equal to median. It is also equal to the Q2, the second quantile, right? Q2 sometimes is called a second quartile, first quartile, second quartile, third quartile. All right, so that's the something, and obviously you're gonna know what is the, I just made another example. What's the 7th decile? Like a descent. This is called a descent. This like a DIC is like a 1/10, right? Decile means 1/10. Okay, so 7th decile corresponding to the range of percentile from yeah, so decile on the website, I believe my understanding, some of the Google explanation might be incorrect. So what they think, decile same as quantile, exactly the same. This means exactly the same thing equal to 70%. That makes sense. Or it's equal to 7/10 of the chance. So once you got that, we can easily plug in this statistical knowledge using the question that are the example that we have did. We can do some examples, right? Do some explain some of the real examples. Let's flip to 6B. Do we have any example questions? 16B, sorry. Yeah, the median, right? So this is fine. And this question is a exponential. Yep, we can do that. What's the decays on the first day and after the first day? All right. So what is the T? What's the K? K is the days, right? Observe the time X days that, all right. Let's do that using example, because the beauty to do examples is that you're pretty sure the solution is presented. So even if you don't know how to do it, you can just go back to see the solution. But chances are you might be better. Because I told you that textbook is just a way of servicing average people. So it's highly percentage of chance your method make it through better than the textbook method. So that's what I found, right? So hopefully you find that as well. So you go that, and if you can work out exactly the solution, and you will be confident, you just quickly scan through the textbook solution, compare whether his method is faster or your method is faster. Do that, then you have a conclusion. Say, okay, and nothing can learn from that solution. I do my own way. Or you can say, oh, that part of solution is better. So I just learn that little bit, add it to my strategy list. So this is the way called active learning. You don't learn the whole thing to just stack into your memory, which not integrate to your existing knowledge. That way your learning is pretty mess, right? Because you just literally like receive a puzzle. It doesn't put it in the right shelf. So all I want you to do is you are using your knowledge from the shelf first. If it works, you don't need to learn anything. You just practice. But if you find something is better than your one, you check that little part into your shelf so that you still maintain your bookshelf is nice and tidy. Okay, so this is the difference between good student and average students, right? Average student just learning things without organize them. Without organize them, then the time when the question coming, they based on their random memory. This means like based on whether he can find a puzzle that are randomly put in the storage room. Sometimes it just, oh, where are they? Like this is a very common feeling. Lots of students say, oh, I can't remember what to do. Basically, the reason is not because your memory is bad, it's because your habit is bad. It's because your study habit is not organize the things. So good and bad in terms of math is organizing. Okay, so if you understand organizing your knowledge, you will be successful in not only math, but also physics, potentially chemistry. I can't say that much because personally, I'm not very good at chemistry. So I feel like that method may not be perfect working, but I guarantee you the method works for physics and math. right? And also for some kind of concept for economics, because I do economics and actuary studies. Yep. So those method also works for those quantitative, but not too much of memory, right? Because I'm not sure how the method works for biology or some other things. Maybe there's lots of other random skills needed to memorize, but we just talk about math, right? If you want to be good at math, do this, right? Tidy up your bookshelf, right? The bookshelf means your memory. All right. So the way to do that is starting from doing examples without looking at solutions. So let's do that. Say whether it can learn something from the textbook or not. And you can feel free to do the same. And the question is already in front of you, right? So you got a question you already have. Let fx and fx both are the same. Ooh, do you feel that a little bit strange? Maybe, right? You say, oh, is it possible? Okay, we can just hang on there and be the PDF and the CDF respectively for the experiment. All right, so this is respectively means there's two questions, right? So we don't know. Let's see what they mean. Respectively, this is two questions. Describe above, observe the time X days that nuclear survive before decay. So let's just quickly draw the diagram, right? You have quickly say, oh, what's this? So this one is E, and E is going downwards, and this point should be 1, but because of that, you don't know yet. It is, right? It is 1, because when the K is 0, it is still the 1, so that's 1. Then you have something like a gone forever. You don't know, right? So this is called PDF for sure. Let me start with that. Okay, the K is given. K is given, so this question is initially the fx equal to e to the power of negative kx. You can put a k in. So it's a ln 2x, the x need. So here's a little bit writing skills. You don't want to confuse yourself with the log. So you need to write this, right? E to the power of x ln 2. That way is better than some students just write negative ln 2 and x. Do you know what's the risk you're having? You, after a few steps, yourself will mistakenly believe this is 2x combined. That's a risk. So the good habit is regardless, whenever you have log or surds, you leave the surds at back. So like 2 root 2, right? You never write it as a 2, 2. That will, after a while, you might merge them into it and you got wrong. So make sure this is all at the end. The coefficient should be in the bring in the forward, same as log, right? Log, particularly ln 2 and time x is a bad habit to write. You can't write like that because after a while you will cheat yourself, right? You will just misleading yourself. The best way is write this way. So you will never get wrong. That's the correct way of writing. Are we clear? It's very important, right? Because you will losing lots of marks because of these mistakes in the future. If you're doing that, I'm not saying I got to take your mark off. I'm saying if you write like the wrong way, you're gonna eventually mislead yourself and get the wrong answer. Therefore, it's an algebra careless mistake. So try to avoid that at the very beginning. All right, so let's move on to just looking at that. Looks like pretty messy things, right? Now, say explain why the domain of possible value is unbounded under 0 and so yeah, because this is nothing, right? Because it is a exponential. Why the domain is that? Why domain that? Because You can just, because 0 to indefinite, you can prove that. Because that's equal to, you can do that. It will end up with, let's see, it's k, do integration. How to do that? You put it in. Let's remind you how to do this. D negative kx. So you put a negative k in the front, sorry, 1 over negative k in the front, because you bring them inside. That's called a reverse chain rule method, right? You make them the same. What I'm saying is make them the same. Okay, once you make them same, you can using the rule of that. Otherwise, you can't use this rule, right? Because once you make them the same, you can just go straight to end up with the next step. Okay, so negative can turn around. So I'm just showing you basic integration like skills, right? You can negative can be digested by turnaround, 0 and the negatives. So 0 on the top, positive, negative at bottom. Now you are doing the 0 first. When you put a 0 in, it's just 1. Then it minus, put an indefinite in, you find e to the power of negative indefinite. It's a 0. So the result is 1 over k. Okay. So if that's the case, it's 1 over k. I think the question is very tricky, right? It's not correct. If you put him into this calculation, you get 1 over k, but if the k is this, how that possibly to say this is 1? So it's not 1, right? Explain why domain value is unbounded. Now, I think there is something, it's nothing to do with math, it's more like understanding the question. Let's go back to see the question. So this is where like say, oh, I must be somewhere wrong in terms of understanding the question. Let's see what they explain. The experiment is extremely unlikely to last beyond a month or 2, but it is minutely possible that it will continue over 10 years or even more. Thus, we used unbounded. This is just a random explanation, right? It's not that. So why this is K? I think here is a typo. I feel like there is a typo. This question, the PX. So I think this part is totally wrong. I don't understand what they talk about here. It can't be like that, right? And because if you're looking at this, if let be equal to this, I think it must be missing something. So I believe that the correct way should be this. Okay, so I think the correct typing should be let fx equal to this, and capitalize fx equal to this, where k to this respectively. That makes sense, right? Because that makes sense to the diagram of this one. Because think about if it is e to the power of fx, put a 0 in, that's 1. But the question says this is k. That means they have missed out a definition. So now we're clear. Based on that information, we're 100% sure that's wrong. So everybody just add a little bit things in to the question because this is a typo in the question. So what typo you should fix is this, right? Replace this part, or maybe you can insert some part here. Just say it's a 0 equal to k e to the power of negative k that. So the information, if you do that, the whole sentence reads perfectly makes sense, right? So you can say let fx equal to this, capitalize fx equal to that, where k is this, be the PDF and the CDF respectively for the experiment. Now everything makes sense. Particularly makes sense to this diagram because it can't be possible where the f0 is 1 is k, while the original PDF doesn't have a scale factor. The scale factor have to be k to make this diagram meaningful. Hope that makes sense. So now I know why I'm stuck, because this question is wrong at the very beginning, right? So that's the correct way. So now if you roll back to the question we are trying to do, now we understand. The initial understanding here is the missing word k. If you have that k in, the whole thing is different, right? So you will have a result, k is canceled out. At this part, k is 1. So you don't have a k. It's obviously, this is validation, it's 1. So I don't need to calculate the k. It's fine. But that exercise doesn't deliver anything, because you don't need to do that. But the question is more, makes sense now. For the first question, say why that's equal to 1, my language will be saying, because given that, if you're doing integration from 0 to positive indefinite, it's equal to 1. Therefore, you need a domain from 0 to positive indefinite. The question asks you where it is to the positive indefinite, because only that way, theoretically, it is correct to satisfy the basic definition of the question, right? So that's fine. That's A is still good. So that means it require domain 0 to positive indefinite to meet criteria of it can't say I'm wrong, right? I'm still correct because the question asks you why you have to go to positive indefinite, because you need to. Otherwise, it's not adds up to 1. Full stop. That's valid, strong reason why you need to extend to positive indefinite. The second point is find the formula for PDF. Find a formula for PDF, and so this time, I think this probably is the question that they didn't tell you, right? So it should be this. So now find a formula, you will say, okay, then you need to bring, in this case, like the k is something you need to solve, right? So if the question is not telling you, I can still do that. I'm saying, like a letter you have to let the formula, right? Because the letter the formula is, so the formula, how to formula find a PDF, the formula is this. Fx is a derivative of fx dx. So the derivative is going to be e to the power of negative kx, take derivative. That will become itself, okay? And you have a negative k in front. How's that possible? Let's see. You take a derivative, you will have a negative k in the front. But do I need a negative k? I don't need a negative k, do I? So let's go to the negative zone. Take the derivative. Yeah, that makes no sense. Is that right? Let's see what the question is doing. Make no sense, right? B, for the CDF, the CDF is this. So it does make lots of difference, right? So the question is obviously wrong here. So for the CDF, this is also a typo, right? Because they are completely miss out lots of things. Okay, because of CDF, differentiate, you got that. Okay. So guys, you need to make two fix. Otherwise, this question is make no sense, right? So one part, this one, you can argue this one is not provided because the question is not supposed to tell you. That's fine, but you need to make a change for this. And you can just take this away. Given that, where is this? And also PDS is FX, which is so far is unknown. Basically, the question is like that. Now we know. Okay, so that way you can take derivative. Let's go back to again. This question is ridiculous, right? So this one, the initial question is given like that, and you're doing integration, still following the same rule. So hopefully we need to make some change. Maybe we should tell Cambridge they're wrong. Right, so that one is yeah, you take 1 minus e to the power of negative kx d dx. The 1 will disappear, negative will stay, that one will stay, and finally negative k will stay. Is a chain rule factor. Cancel out, it become k e to the power of negative kx. I just slow down to work you out. That's the result. Now everything makes sense. Now everything makes sense. You can add up and you draw the diagram. I skip the diagram for the PDF. Maybe I should. Let's just put a diagram in. I drag the diagram here. So far, you don't need to substitute to the k. Just leave the k in. It's totally fine. You do not require to substitute to the k. So in this case, the fx. Now I think we understand the question and understand where the question was wrong. All right. So the PDF is given as a 1 over that. So it's a kind of like a graph drawing things. The question initially, the questions look like. 1 minus k, oh no, there's no k. 1 minus e to the power of negative k, that one. That's called a CDF. All right, so what you draw the diagram, it's basic standard, right? When x is 0, what's the value? When x is 0, right, you will find the whole thing is 1, and 1 minus 1 is 0. So the starting point is 0. But when x is positive indefinite, what's the result? That's 0. So 1 minus 0 is 1. So you know there is asymptote here. The asymptote is give you the line that is where CDF is equal to 1, right? So like the fx is 1. The f positive indefinite is 1. So then I think you got 2 points and try to understand what's this. Quickly sort of merge into your existing knowledge base. Let's just quickly do that, right? It's more like a function transformation. When you have positive a, you go that way. But this question is negative a. So you go downwards, right? That was your initial drawing. Then you put a negative sign into it. Everything turns to the other side. Yeah, because that's a change to the y, right? Because you put a negative time everything to the negative, you go to that. But then you add a 1. You're shifting this one upwards. So when you shift up, you initially, this point is -1. Now you shift up by a 1. So your whole thing is going to shifting to the new asymptote line. Okay. But then finally, you're looking at the domain. It's cut off the domain, right? You don't have anything below 0. You only have that. So that's why the curve should look like that. So are we clear? So now you can connect them. Okay. So hopefully that little brainstorm goes through, let you sort of feel no surprise. It's the same as what you learned before. It's simply just missing a few steps. You feel like, oh, it's a new thing. No, it's not a new thing. It's existing knowledge. Just simply doing a function transformation and you get there. All right. So once you get there, you have the 2 diagram. B is done. Let's do C. Find the median, show that it is the half-life. So median, again, as we just said that median is equal to Q2, equal to the probability of this called X, right? The X less than equal to Q2 is equal to 50%. Right? That basically is the requirement. Now find Q2. How to do that? You have 2 options, right? Are you doing integration anymore? No, you don't need to. Why? You already have this f. Because you know the fx, let's just recall that, right? 1 minus e to the power of negative k. That's the fx. So when you put in the value of, you need to find a value of x that equal to 50. Basically, it's the equation like that. So you populate x in, which the x is already here. So you try to find, if you want to say, right, maybe I just using the correct terminology that you can make sense, right? So I just basically, it says this. Because of that, therefore, you know, f q2, it's equal to 1 minus e to the power of negative k q2. That's equal to 0.5. Does that substitution make sense to you? Because x is a general term, right? When I substitute q2 in, the q2 is a number. We know the q2 number is the one that we need to solve. But then you put a q2 in, right? You're following a q2 equation, an equation related to q2. Now you solve the q2. Now you solve the q2. It's just move this one to the right-hand side and move 0.5 to the left-hand side. You will have e to the power of negative k q2 is 0.5. Yeah, because you just solve it. Then next step is going to write out what's the index. We all know that, right? What's the index? It's log 0.5, which is negative ln 2. Are you good at log? That's something you need to do quickly, right? 0.5 is half. Half is turn around. There's negative in the front. So now both sides have negative. Therefore, next step is kq2 equal to ln 2. Okay, so now you know q2 is ln 2 divided by k. You're not done yet because you know the k, right? The k is these things. So it's a log 2, ln 2 divided by 8. So you work it out. Actually, the Q2 is 8. So just have a sense check. Say, is Q2 equal to 8? Because this is indefinite, right? You will say, okay, Q2 equal to 8. Yeah, possible. Why not? You just put 8 here, right? So this is 50% of area. This is 50% of area. Or you can say this is the Q2, 0.5. You basically solve this point. This is the 8. So are we clear? Well, can we easily map out in the two different diagrams? So one, this diagram is very clear to you. You don't have ambiguity understanding. So let's just repeat, right? See, CDF, the vertical bar is not probability. It's not the, what should I say? CDF actually is the probability. Okay. And the PDF is not probability. It is the density. So you now understand why we call that PDF is not probability distribution function. We call density because this one is not probability, it's the density. Density means they are not probability. They need to do integration, it become a probability. While CDF, we call cumulative distribution function, right? So that's actually is probability. So you can say if you want to solve a equation directly linking to probability, you can either link that probability to an integration of PDF, or you can straight away link into the value of CDF. So I'll say that very slowly, hope that makes sense. A probability is going to equal to, if you have a given probability, right, it will equal to this. I think it's dt. That's one option to solve, but the other option is you just straight away load into fx, right? Fx minus some other value. But if that value is the beginning, right, it's a Q1, then it's just a 0. But basically you can think about fx is equal to the probability. So the solving strategy is different, right? Because this one you have to carry integration before you can link to a probability number, while fx is straight away linking to the probability number. So let's see whether we do the same. Look, right? We're using fx, means we're using CDF, and I directly link into the probability. Can you see that? I'm directly linking the value to probability. Did I do any integration? No, I don't. Right? So because fx is already the probability, so you just solve it. So make sure that you are clear in this kind of important knowledge triage, right? If you got a PDF, do integration to link the probability. If you got a CDF, straight away equal to the probability. That can be done by that statement as well, looking at a diagram. So can we see for the 0.5, you can clearly write as a y bar value. The vertical bar value is 0.5. But on this density function, 0.5 is nowhere you can write on the vertical bar. Instead, it is an area. That makes sense, right? The area means it's corresponding to a probability. Now, I think hopefully that makes sense. This is really the most hardest part for continuous probability. If you get that clear, nothing's hard. The remaining things is very easy. You just check in the formula and you understand who is who. That's basically what we're teaching today, is try to understand who is who, right? Because you don't mismatch the formula. Because so many formula, it's very easy to apply the wrong formula in the real case. Let's see whether we get 8 correct, right? So this is an important sense check. If it didn't work, you need to get the value of, yeah, it is 8. So it's good. So the last part, it's easy, right? Let's see the last part. Find the probability that it decays on the first day and after first day. It's just populate the number, right? D, what is the probability, like on the first day. Whoa, what's the date? Say again. What's the probability? Let me read the question again. The question again. Find the probability that it decays on the first day. All right. So the question is saying, probability on first day. So how do you interpret that? You can interpret that diagram, right? On the diagram, what's the on the first day mean? First day means from 0 to 1. On the first day means this is the area you talk about, okay? From a PDF perspective. But if you want to from a CDF perspective, it is, right? It's actually is you just talk about this point. You try to find what this value. So which one is easier? After you assess the task, so this is question ask you that value or ask this area. But obviously after assessment, you say, CDF, I'm already know, right? I'm already know. So it's going to be saying, I'll do fx equal to, I just calculate f1. F1 is telling me this data value. So f1 is clear, is 1 minus e to the power of negative k 1. Yep, so that's it. And you can, using your calculator to sort it out. One minus e. Where's the e? Let me see the exponential button. Where's my exponential button on this calculator? E. Where's the e? I just suddenly lost it. I should be somewhere on the. Oh yeah, here I got it. Okay, so it's a shift on the log. 1 minus negative k. Negative. So what is k? K is a big number. All right, maybe we should spend one more step before we apply into the formula because the k is another value. So we should simplify before we punch in the calculator. So e to the log 2 k. And what that means? That means 1 minus e to the power of negative ln 2 to the power of 1 over 8. It's a bit of a random. What's that? That's actually is just put a negative in as well. So that's a negative. Okay, so it's 1 minus 2 to the power of negative 1 over 8. Yep, that because you take e and the log is cancel out, everything is inside. So this result should be the exact value, but we can try to calculate now. 1 minus 2 to the power of what? Of negative 0.125. With that's the negative 1 over 8. Equal to 0.082995. So what's the rounding requirement? So if there's no rounding requirement, keep the reasonable decimal point. In this case, I think if there's no rounding requirement, you will say 0.083. A little bit dot there. This is the probability of 8.3. 2 decimals, good enough. So what the question says, next one, what's the probability after the first day? So you don't need to do the calculation anymore. What's the after? After first day. After first day is tricky. right? You can just looking at a diagram. What's the after first day mean? So we just done that. This part is 0.083, and this part is 0. So after first day, let's say using the green color to demonstrate what that means. After first day is means this area. That's everything after first day. Okay, but if you want to looking at CDF, where is the after first day? Because everything gonna split mutually exclusive, either in the first day or after first day. They all add up to 1. Does that make sense? So after first day actually is this part. Okay, so can you just using diagram to clearly see where you are? So not only just looking at the equation, say, oh yeah, that's the way. You want you to put everything on a diagram. You match it out. After first day, it means 1 minus 0.083. That's a 92, 0.929, sorry, 0.9, 0.917. 0.917 is the probability after first day. Okay, so I guess we should take a short break now, and the whole purpose slow down, right? To get that, because I noticed that prior year is very confused. Students like learning this, but not really understand this. They do the question correctly, but they still very feel like unconfident what really is the continuous probability. So hopefully that process, we not only fixing the typo, but also go through the detail, the connections between algebra versus diagram. Okay, so take a 5 minutes break, returning 20 past 11, returning 20 past 11. Thank you. All right, guys. So I think I fixed the bugs. So next time we will get that question correct. The question 5 typo has been fixed in this in the notes. All right. Cool. All right, let's continue, guys. If you back to your desk, raise your hand. Let's continue. So now we try to scan through the knowledge that we have done, and then we can continue. All right. So if you back to your desk, raise your hand. I need this 5. Come on, it's only 4. Where is the 5? Excellent. Cool. Let's continue. All right, so the example 5 we have done. So example 6, I think it's a similar, because as long as you understand one question, everything else is same. So I think after the conversation, we want to just write down what do you have learned and take away. You have takeaway is that CDF, PDF, they representing equivalent information. I mean, they provide adequate information from different perspective. That should be the correct way to say it, right? They provide adequate information from different perspective. So when you try to solve a question, you should quickly, even doesn't provide a visualization, you should try to have this visualization in your mind. Then you will choose the correct way, easy way to get the results. So for example, the question we do, the question D, you can have option of PDF to solve it, or you have also the option using CDF to solve it. Obviously, the question is easier to using CDF to solve because you already have that. So the entire exercise that we are doing here is all pretty much everything is linking to PDF. There is nothing linking to integration at all, right? But there is not always. There's most of the question that we have experienced in the HSC. They are related to integrations. So last week we have done some homework. The purpose is try to reinforce the concept of what is the basic requirement for PDF and the CDF. And then today we talk about what is the quantile. So for example, the question 6, did I ask you to do the 6 last week? I think I did, right? So question yeah, so 4, 5, 6, 6 is the one. So basically, I do ask you to sort of do the 6. And for the question that we have here is the uniform distributed diagram. It's a uniform distributed diagram, right? It's called yeah. It's a probability density function or PDF defined on AB. The cumulative distribution is that, right? So for each of these, try to solve the parameters. Try to find the parameters where what's the parameter of B so that you can solve it. For the question, the PDF for part of AB of the question 5. So let's say AB. Okay, so one of them is a straight line PDF. The other one is a quadratic PDF. They have some definition on that. In this case, A is 0, B is 8. Yeah, that's fine. Try to find what is the median, okay, and what is the quantile 1. So now I think the question you see, there is explanation of what is a Q2, what is Q1. But in the harder question, not harder, like in the real question, you might not give in a detail, right? But you're not complaining, say, I don't know what is a Q1, what is a Q2, okay? So you know what is a quantile Q1 mean? What is a median Q2 mean? By default, you should understand that. So in order to sort of get to this question clearly, let's just understand you do Q2 and Q1, okay? The question is these two. So let's just practice, because I know some of you guys may not have chance to practice. So the question is this. you need to exercise personally. So we don't like we won't learn unless we try it, right? Because this is the question you are going to have. The question is now this, right? So find Q1 and the Q2 for below questions. So everybody give a go for that. I know you guys already did homework for most of the students, but some students probably never did or did incorrectly or unable to deal with. So hopefully take this opportunity to do that just once, and you should be able to. So I'll ask 2 students to come up to give a go, right? So let me see. Okay, so let's get Rocky. Can you do question B? And A. Okay, so both you need to do Q1 and Q2 for both, right? A, can I get Daniel to do the A? Everybody do that on your own space, right? Even you did before the explanation, now do it again using the concept and understanding you just get from our discussion, right? Do it again. See whether you can do it properly, logically, how to get that. So this exercise require integration. It's require integration, but what is actually the correct way of doing it? Yeah. So let's just let's discuss that. What's the correct way of doing it? Particularly the question B, Rocky, is hard because Daniel, when you did it correctly, you may or may not be correct because you're not learning the full story. If you say fx is this, why not? But the challenge is you need to know what is f, what is the q0 basically, because everybody you need to understand where is q0. For Daniel, q0 is 0. For Rocky, q0 is -2, right? So some students say, hey, you said a PDF to have to be positive. How come Rocky's question, the x is negative? So is anyone can understand that question? So why? Somehow have to be positive, but why this negative? So then you're gonna ask yourself, which one is positive? It's actually the vertical bar is positive, right? Because you need to have a curve above x-axis. Never ever expect all the x is positive. It can be negative as well, because x can be saying is a payout figure. So like sometimes you win, sometimes you lose. It's totally possible, just like the casino game. You remember that? So you can think about x is the casino payout, sometimes positive, sometimes negative. So it's nothing wrong with that, right? So just try to clarify on that. So Rocky, I think you probably let's just getting the diagram clear. Can we get the diagram clear? Rocky, draw your diagram PDF, and Daniel, draw your diagram PDF. Because doing integration without understanding diagram is a risk. Rocky, are you sure? Rocky, are you sure? Are you drawing the FX, or please draw the little FX? Draw the little FX. Because only when you draw the little FX, you can draw the capitalized FX. So everybody draw the little fx. That's why I said if you want to put a weight on PDF and a CDF, I would give you recommendation is 7.3. Your more effort should put onto PDF, less effort put onto CDF. But CDF just like a shortcut. Shortcut is not always available. So that's a 2 sentence, right? CDF just like a shortcut, but shortcut is not always available. Shortcut, if you blindly apply shortcut, you might have mistakes. So I think both of you had an incorrect FX calculation at the beginning, but Daniel, by luck, you did it correctly. Because you know why you did it correctly, Daniel? Because your F0 is 0. Right? That's why you're correct. But Rocky, you're wrong because your F0 may not be correct. I don't know, right? You need to figure out what is F0. It's not F0, so you need to figure out where are they. You should know. The question is like that, Rocky. Before you do anything, the boundary requirement is very important. -2, that's a 0. +2, it's 1. That's your boundary condition. For Daniel, your boundary condition is F0 is 0, F8 is 1. Are we clear? That's a very important starting point. If you make sure the boundary condition that is not wrong, then everything you are calculating is possibly to be correct. So like, I will put a question mark, Rocky. Do you really understand this? Is it correct?
Question,
So,
I didn't get like the part where you talked about the boundary.
so the parts boundary is you go to the fundamental of CDF. What does CDF mean? CDF is a cumulative probability distribution. If your X had a domain, say A to B, you by default, the left-hand side boundary give you 0. The right-hand side boundary give you to 1. That's called a probability. We get that?
Yeah.
So to test your result, is that correct? If you test your result, if this is your result, right? If you test F -2, you should expect to 0, but you don't. You get a number that is called half. So what's wrong? Where is the problem to adjust? Does that make sense to you? You find yourself with incorrect FX being calculated. While for Daniel, because the F0 is lucky, is a 0. That's why, although he didn't follow the correct calculation, guys, but you guys, yeah. So how about I show you the way that correct way of doing it is this, right? You basically try to find an area that is, so for you, right? Rocky, why I'm asking you to draw a diagram. One thing is very clear. After draw diagram, doing nothing, you will say Q2 is 0. Are you happy with that? Because that means at a point of 0, you are bisect all the probabilities. The left-hand side is 0.5. Right-hand side is 0.5. So you're pretty sure Q1 is 0. All right? And by diagram, what is the Q2 is 0. So what is the Q1 by diagram? Q1 will be somewhere here, right? So you will be without doing any calculation. If it's multiple choice, do you need to do calculate? No, you can guess where is Q1. Q1 is something like -1 I don't know, 1.3, 1.35, or 1.5-ish. So my hypothesis, right, is that the -1.5-ish, right, should equal to 0.25. By the diagram, can you see that? So this is the high-level assessment you already know. So all the math is only try to help you to find out the result, precise result, rather than let math driving your understanding. Math is not driving your understanding. Probability concept is driving your understanding. So I hope that makes sense. That's why I repeat, visualization of PDF is extremely important, right? You can't get it correct unless you draw PDF, guys. Draw a PDF diagram will save you a lot of time and also will save you from falling into the trap. All right, so we understand that. Now you need to find out what really is this number. So by this diagram, is that hard? It's not hard, right? You can choose your easy way to calculate. You can either choose, say, -2 to this Q1 fx dx equal to 0.25. You can do that to solve Q1, or even by diagram, because of this unique shape, you can do this 0 to, sorry, not 0, it's a Q1. You can either doing this Q1 to 0, because that's a special case, right? You might find yourself faster to calculate that second one. Now, does that make sense now, Rocky?
Yeah, okay.
Using diagram to solve the problem, rather than let the problem solve the diagram, or maybe let the equation solve. So firstly, I have to say, you guys, this is wrong, right? This is the wrong method. And Daniel, this is wrong as well, right? You can't do that because you don't know whether it's true. But once Daniel draw the diagram, I look at why he's correct by any sense, right? Why he's correct, because he will find out this result is that he will find that the starting point exactly overlap with the f0 is 0. So it is something you're pretty happy to deal with, because the function he create validate that, right? If x is 0, it is 0. When x is 8, it is a 1. So although the calculation was wrong, but the result was correct. Does that make sense? The result is correct. Why? Because he can validate these 2 points. So why your result is wrong? Because you cannot validate these 2 points. So are we sort of learning something here? If you really, really want to do FX first, you need to work it out and validate these things. So in the other way around, you should doing a plus C things, right? So let's just play around this number. So the, Rocky, let's play this. So if your result is correct, but the integration need to plus C. Do you got that? You need to plus C. You didn't plus C yet, right? Plus C. So once you have x3, 16 plus C is the result. Let's check in the result, say 2. You put a 2 in. If you put 2 in, you should expect a 1. So you solve the C. If you put a 2 is 8. So C is half. Can you see that? So you work it out, C is half. So the fx, basically, you can work it out is x to the power 3 divided by that plus half. So now you're correct. Now you're correct. So if
Wait,
that's the case,
so
yeah,
can't you just like solve the integral which you said like below, which is like the integral from Q1 to 0 fx dx equals 0.25. Can't you just solve that?
yeah, you can. That's why this question provide many, many solutions. So let's just probably, I think this is definitely worthwhile exercise, because this, I don't think Rocky's problem is unique to him, it's to everybody, right? This is a problem very common that a student confused. So let's explain in the detail how this question should be done. First of all, I confirm Daniel, the calculation was correct, right? So this one, you got that, and you load in this value, you got 4. Test it out, 4, 16, yep, that's correct. 2 is half, you got that is 32, root 32 is that, correct. Okay, so Daniel, done, well done. But I'm not sure Daniel understand this though, because the question is is tricky. So let's explain. Are using the space where Daniel is. Are using that space to explain what the what Rocky's question should be doing. There is a two method. Actually, there's two high level strategy and a three method. Hopefully not confuse you too much, because I already show you there's two methods if you're doing integration. So let's probably high level to summarize this kind of question, what you should do, right? And what is the correct way of solving it? So let's classify these two different methods, right? The method one is from direct PDF. I'll probably call that PDF approach. Yep, PDF method. So what's the PDF method is? I'm talking about question B. PDF method is you quickly draw that. And you find out, oh, it's not really is on that line. The A is okay. So that is the PDF. Okay, that's this one. Cool. So the PDF method telling us if you want to do Q2, it's the probability of the X that I should say this, right? In order to calculate Q2, you have the probability of X less than Q2 is 0.5. By the diagram, due to the symmetry, you immediately see Q2 doesn't need to do any effort. Q2 is 0 because both sides are bisected by the PDF because the density shows they are equal. Okay, done. Q1. To calculate the Q1, you will say, I need to bisect this area. Right, so this is 0.25. That one is also 0.25. So now you want to calculate the Q1, you have two methods. Either using the first part, which is authentic correct method, but for this particular question, you have a shortcut using the second part. So because Q2, you will say Q2 to 0 fx dx should equal to 0.25. So the way how to solve it is you just checking, right? This whole thing. This is 3/16 is the parameter. Fx, you will get that 2, 3, right? 3. That one you substitute with the one that you just say, Q2 and the 0, right? And what you got a cancellation of this one first, so you don't have so many troubles. First, load a 0 in. If you load a 0 in, it's a 0. Then you minus the Q2. So you got Q2 to the power of 3 divided by 16 equal to that. So how that possible? Negative, is that bother you? No, trust yourself, right? That was correct. Why? Because you will figure out if you cancel this 4 out, it's a 4. So take the 4 to the other side. You will figure out negative Q2 to the power of 3 equal to 4. That means equal to negative 4. All right, so then you work out that Q2 is negative 4 to the power of 1/3. Because negative is, you can take cubic, can you? Of course. So if you want, you can just write it as negative 4 to the power of that. Yep, so or maybe precisely, it's negative cubic root 4. That's the way how you solve it. Okay, that's the so-called first method. And so I'm sort of making the clean them up. So I'm not doing so many messy things here. I try to make it clear. Let's write it in a more easy way. Negative 4 to the power of 1/3. Done. All right, so this is the method, PDF method. By the definition, by the combination of PDF, everything, done. Let's see what's the text message. Oh yeah, Q1. I'm being using the wrong script, right? So Q2 is already worked out. I just change this back. It's a Q1. I'm calculating Q1. All right. Thanks for reminding me. All right, so Q1, you calculate that. Have a sense check. Say, is that negative number? Yeah, it is. Q1 is negative, so that's fine. And if you want to have a particular sense check, see what's the number really is landed. Have a curiosity, right? Let's say 4 to the power of 1/3. That's 1.58. So it's a negative 1.58774. Okay, that makes sense. It's pretty close to my previous guess, right? I thought it's negative 1.5 is roughly my understanding, but I need a calculation to work it out. Down. All right, that's the method of PDF method. So the second method, I might just need to using Rocky your place, right? Because I think I want to follow your method, but I try to see whether your method still have a solution. I had to think about it. It is yes, it is possible. So let me clean up the stuff that I have drawn here. All right, so the method 2, I'm calling this is called a CDF method. You may not need a algebra, but you need a CDF IVF method. Do you remember what is IVF? Initial value, not IVF, IVP. IVF is the other name. All right, IVP problems. So it's initial value problems. So let me show you how that works. So when you do integration, you remember the things you forgot, like a Rocky, you forgot one important things. When you do the integration like that, right? So you say fx is integration of you asked me whether I agree. Yes, I'm agree. Yeah, it's fine. Do that. And once you've done that, it's a 3, 16, and a 3 over x to the cube, right? And do you have an up and a down? This is called indefinite integration, right? It's fine. What do you do? Plus c. So obviously there is a cancellation, right? So the result is x to the power of this plus c. So now you got to use boundary condition. Using boundary condition. So what is a boundary condition you have? So based on the logic of CDF, right? Once you got CDF, because what's the boundary condition again? It's a f -2 is, because that's the boundary, the lowest the boundary suggests the probability less than this number is 0. Yeah, you just use that. Or you can using the boundary condition of that equal to 1. Whichever one easier for you, it's fine. Let's use this one. Okay. All right, so you substitute in f -2. Sorry, actually using the normal color. That's equal to -8, right? Divided by 16 plus c equal to 0. It's obviously, you work it out, c is half. So now you have the CDF fx is what? is x to the power 3 divided by 16 plus half, which you can say. So that's now is your CDF. And you have a sense check. Check what? Check f -2. You already did that, right? So check the second point. You see, check 2. If you load 2 in, it's half plus half, it's 1. Yep, the check fixed, right? So you need to have a CDF so both boundary conditions are satisfied. Yep. So now you're pretty sure that's a correct result. You're pretty sure that's a correct result. So all you need to do next is saying, now I'm solving f q1 equal to 0.25. Yep. So q1 to the cube divided by 16 plus half equal to quarter. And I solve q1. Is that hard? No, right? It's a -1. It's a -1/4 here. -1/4. So q1 to the power 3 is -4. Yeah, that's a -1/4. You move the times 16 on both sides. So -4. So you work it out. Q1 is -4 to the power of 1/3. Yeah, because we know the negative can take outside when you get that. All right, so second question is Q2. You know that's equal to 0. So you substitute in Q2 to the 3 divided by 16 plus half. That's the equation, right? Equal to 0. So you solve, what's a Q2? Q2 is 8. No, Q2, yeah, Q2 to the power of 3 equal to, this part is weird, right? Why this one is 0? Oh, yeah. Okay. It's still not right. Let me think about it. What's wrong with that? No, Q2 is not 0. I'm being silly. Q2 is half. Yeah, Q2 is where the second quartile that the probability less than Q2 is half. So it's not 0. Okay, so that makes sense now. So that's why Q2 is 0. Yeah, so that will be a 2 complete method to solve question B. So I think this way you are getting the skill set ready, right? So this is what I exactly says. You based on the knowledge, you may not understand what takes. Once you did this question, you realize, oh, actually, I have 2 kind of different strategy that I learn, right? I learn one is if I like a visualization, I stick with PDF. Every single time, I just need to find out all those visualization and the patterns that I can observe from diagram, and I'm gonna calculate exactly the area underneath of PDF. That works. Agree, that works. Okay. The second way is saying, if I'm saying, oh, I want to separate the problems, I want to reuse my effort of doing integration. I'm not liking doing integration every single time. Fine. So what do? You're gonna do integrate by a indefinite integration methodology, but you will have a plus C, which Rocky you forgot, right? You need to plus C because this one doesn't tell you C have to be 0 from very beginning. Then important things, this is where probability is stick around, right? Probability knowledge tell you the boundary conditions. There is a boundary condition, either the left hand side of domain is 0 or the right hand side of the domain of the PDF is 1. Right? So this kind of things, once you load it in, you can calculate the C. Once you calculate the C, you have a complete CDF. with the sense check, you still need to double check your result where the boundary condition is being satisfied. Does that make sense? The boundary condition is the key for you to understand the CDF. All right, then you just, now the final steps is just substitute into the equation to solve the Q1 and the Q2. Based on Q1 is 25%, is the first quantile, and Q2 second quantile, it's actually the median. All right, so I think that will be a good wrap up for the purpose, because I think we are doing quite a lot of calculation. I noticed that they may not be that easy, so that's why I take slowly, go through this. But we have lots of questions we haven't done yet, right? So what we're gonna do today, we will try. There's so many questions. Let's just quickly using the last. I probably can extend a little bit today. At the beginning we just play around the recording too much, so we will probably have another 10 minutes. So when Jack at work, let's just quickly looking at the questions. And do you have issues? So what's the probability will be stressed? So there is a condition is only stressed in Jack's quiet neighborhood. Okay. So this question is just to set up, say, what is the, you need to figure out what's the probability, PDF. So the fundamental question is PDF should be in the proportion of the area. PDF should be in the proportion of the area. So then I think this one is fine. You try to do it yourself, right? So the second question is function is probability density, right? That's easy. So you got that. You got a things look like that. Sketch graph 0 to 1. So you know from the boundary condition as well, when it's this area up to, when it's 1, it's a 2 here. So the area of this triangle is 1. That satisfy this sense check of PDF. You done that? Use your diagram to show that the area underneath is 1. Yep, we done it. Mark a point of X between 0 and 1 on your diagram, and use area formula to show that the cumulative distribution function is this. So this basically saying if you have a point over here, what is the cumulative? So cumulative function density is this red color part. You just calculate this one. So you will say this is 2x, right? So the area for the x is half times x times 2x. So it's x squared. Yep, easy. So you and confirm your result by cumulatively doing integration. That will give you t squared from 0 to x. It also gave you the x squared. Yep, that's easy. So use your expression for the cumulative distribution function to calculate 3 quartile. So Q1, Q2, Q3. That's where it's interesting. So I think this whole methodology is what we have discussed called a CDF method. CDF method. Why that's different to the one that we have discussed? Because you have easy 0 point. So what the boundary here is, they're from 0 to 1. Okay, the boundary is easy compared to the question -2 to +2. They are quite different. But if you say, can I just ignore this? Try to do using this way. Can I use in the C as well? Yes, you can do that. And then, you know, because F0 is 0, so populate C is 0. So that's why, Daniel, when you do that question, I think we can easily just justify that. Fx, do integration, standard, C is something you need to specify. Then load F0 equal to 0, you calculate C is 0. So you work it out. All right, so I just want to sort of reconcile the methodology we discussed. Still works. So do that. Second question, you obviously need to do 8. Try to sort of try your own preference. Now there is a bunch of different questions. Find the value of unknown C. Very good, this one. Given that each function is a probability density function on that. This is a very important exercise, guys, because this one just telling you that what kind of condition you can use. Calculate the C. Calculate the C for this question, for example, it's very easy. You will see the C is 1/6 down. But for other question, not that easy, right? Not that easy. For that one, it's also easy. It's -10. Why? Both of them are something called a rectangle. So all you need to figure out to the C is where is from, where is to. The difference is 10. So that's why this is 1/10. Okay, so B and C is very easy. A and the D, you need a bit of calculation. The D in particular is start to be tricky, right? In particular, start to be tricky because they don't have the C here. They have the C in this spot. Try to calculate the C, all right? So that require your integration, require a little bit integration. So do that. You will getting a better picture of how the PDF works. All right, next question. The formula is graph to the right. Da, 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 da. Okay, so this is called a piecewise information. This is piecewise information. And is that valid? Why not? So what basically it says, if you be defined through 0.5, you quick sense check is what's the area? What's the area? So this is 1/8. So 1/8 times 2, this is 1/8. All right, so no. 1/8 times 2, it's a 1/4. So that part is 1/4. How about this part? That's a 3. 3 times 1/4. That's a 3/4. Yeah, that's to add up is 1. So that's a classic satisfactory PDF because the area underneath of the curve is 1. Although the PDF is discontinued a little bit, right? There is a called piecewise definition. Piecewise definition. Otherwise, this question is not hard. You just need to do this validation, understand, oh, okay, understand now, that's a PDF. Then write down the formula for CDF. Can you do that? So how to do that? You can split it into 2 scenarios. So why? You're gonna say when, if x is less than 2, what is the formula? It's straightforward, right? It's just the area formula for if the x is here. How to calculate? It's too easy, right? This just equal to x over 8. That's it. That's the area. You're done. What about if x is greater than 2? So first you gotta settle the 1/4 because that's a given function already. Then you plus a x minus 2 because that's the area, like if the x is here, for example. So forget about this, right? You don't have this anymore. So if x is here, what's the function? What's the formula of the area that at the left-hand side of x? You simply have this 1/4 here, plus this length x minus 2 time 1/4. Yep, so you got that actually is x minus 1/4 because that's the 1 at the beginning and you got it. Yep, so I think that one is also a good exercise to expand your knowledge, right? Expand your knowledge. So I quickly walk you through how to do it, but I want you to just do it to you personally. You understand that. So probability density function is defined by that. Again, this is, I'm not going to explain anymore, same as question 10, but consolidate your piecewise definitions, the piecewise function capabilities. Define probability definition is this, it's fine, it's a quadratic, can you see that? Sketch the probability density function and state its mode. All right, so let's just quickly recall. What's mode again? So mode, mean, median, right? This is something you should know already. Mean is easy, is the average. Yep. Median is Q2, right? It's a 50% bisect point, probability bisect point. So what is mode? Mode is where the fx, f like mod, no, not f, little fx. This is the mode actually is the highest point. So it's like if you have a curve, right? That the tipping point may not be mean, may not be median. Only when is mean and the median when is a symmetry function. So you say, okay, that's mean and the median are same. But if it's not a symmetry, they are not the same. But mode is the highest point. So understand, mode is the highest point, right? Is the maximum point. So mode is where the function of mode equal to the maximum of, if that makes sense, because fx is a lot of value, but if you do max, that means what is the highest value for that point. So mode means that that particular x you loaded in, they happen to be equal to the max, right? So then some students say, oh, if that's the case, if we have like a weird case like that, do you mean there's two mode? Yes, indeed, there's two mode. Why not? Because if the two of them are exactly the same height, you would have a mode 1 and a mode 2. So that's a typically valid for distribution that is based on a trigonometry things, right? If you have sine x like that, if that is a defined probability distribution, you might easily draw the diagram like saying, oh, it could be a 2 of the curve, right? I can easily set up something to make, now this is the probability distribution. If I'm asking you, what's the mode? Of course you have two mode. But what's the mean? Mean is going to be, yeah, the average point. What's the median? Yeah, of course, Q2 is here because that's bisected by naturally the symmetry. So hopefully some of those easy questions can help you clarify the understanding for mode, median, and the mean. Three things, right? So hopefully you are clear now. Mode, median, and mean is some kind of basic statistics concept that we want to cover, right? So that's good. All right, 13. Yep, that's again, it's exercise for that. You do the diagram. Now you know how to do this, right? It's very straightforward. This is the point of C. So that one doesn't need it, right? So that's the PDF. And the CDF, you will have something look like that. Yep. So otherwise, it's straightforward. You can calculate. There's a bit of log in the result. There's a bit of log in the result, I should say. Yep. 14. Grouping approximately a continuous distribution by discrete distribution, and you figure out. Okay, so okay, so that's pretty much it. Make the enrichment your options. So I think the enrichment might worthwhile only doing 15 and 16, but it's not required, right? It's not compulsory required. I want you to do homework just up to all the question in the development so far, because it's already enough, All right, so I think all the question in the development will be your homework from 7 to 14. And the only question that I didn't explain the detail is 14. So let's recap if you have a challenge. Otherwise, that will be it for today. Okay. guys. So see you guys next week. And we will try to fix this recording issues, but I think this recording is still available. I will distribute, put them onto YouTube where you can see the recording. All right.
Thank you.
Hello. Thank you. Bye bye.